Okay, 318 maximum product of word lengths. Given a string of array words, find the maximum value of length of word sub I times length of word sub j, where two words do not share common letters. Excuse me. You may assume each word will contain only lowercase letters. If no such word exists, return 0. Okay. Uh, hmm. So number one kind of comment is that what was I going to say? I think my first comment is that it's kind of a little annoying that they don't tell you what the maximum n is, because I think uh, uh, well, one thing that I like to do in general is kind of, at least for these types of programming things, is to kind of do the most naive things possible. Sometimes you get away with like if the problem expects you to do something like n squared, which is quadratic, then why would you implement like a linear algorithm, which is way more complicated generally? Right? That's why they're faster, or at least like in terms of coding complexity and so forth, right? So with that in mind, my guess is that is I don't know. I don't know if I want to do the n square algorithm first, but I'm gonna try to do an O of n one first. And maybe. Well, I think so. It also depends on. There are a couple of dimensions to kind of think about this, in which not having the constraint kind of sucks. But like, can you do an O of n? I don't know. But I don't know if I could do it. I mean, because it also depends on like the length of a word or something like that, right? Because that, like, you know, it probably won't be like say 1,000,000 characters, but if it's a long enough thing, then like maybe the optimization isn't on the nested for loop. Maybe the optimization is on kind of words in calculating where the two words do not share any common letters. Maybe that should be optimized, right? And without kind of having these constraints, we don't know how to optimize, which is so that's kind of sad. Like so if you do like a very naive algorithm, which is O of n squared times the cost of a comparison, which is let's just say the alpha for alphabet, then it's just like O of n squared alpha, right? Which maybe we could do better. Like, and in that case, if you have an O of one algorithm that compares two words to see if they share common letters, then well, then you save yourself like 26, say for the English language. Maybe it's a little different. Uh, Actually, did they even tell you it's in English? I don't know. Okay, fine. Uh, yeah. So and yeah, you save yourself 26 speed up. But okay, I'm gonna try to do this in n square, and then we'll see kind of what test cases we fail on, and then so forth. And because of that, I'm gonna either use C or C++ just so that I don't like. I'm just more confident in this language about around constant time optimizations because I don't want to. I don't know. I'm generally speaking, I've been very inefficient with Python. I mean, not like an order of magnitude higher, but like some constant time because I just don't do very efficient things. And that's something that I also need to practice on. But that's besides the point. But okay, let's just say an int should be enough to because I think one thing to think about is like whether this x times y will overflow int, which it shouldn't because that means one word will have 2 to the 16-ish characters, which I guess is a lot. I mean, it's what is that, like 32,000 something or 64,000? So, well, we'll see, I guess. What am I doing? Okay. Can we calculate anything? Yeah, I think actually we could I think having the having the constraint would be better. But I think one kind of optimization we can do, for example, is assuming this is an English alphabet, which doesn't mention at all. Maybe so. Then you could kind of store everything in a bitmask, which is maybe an easy-ish optimization, and then you could compare two words in constant in terms of int time. Yeah, maybe I'll do that, and that should be much faster because that's just a bitwise operation for calculating intersection, right, which I'll show in a bit. Okay, I'm gonna do that. Can I do this? Maybe I could just actually put it here. What is this word size? It's very confusing what this input is actually. A word's size. Okay, that actually is not that confusing. I'm just getting confused. But that means we don't have a length. This is kind of sketch actually. Let's see. Let me just print this out actually real quick, just to make sure that these things compile. Yeah, things are slow today, so maybe I should kind of keep coding while I'm waiting. What am I doing? This seems, I guess, maybe okay. Actually, this is right, so. That means there's no overlap. Back. Maybe I should print out some debugging if I knew that this was going to pend up a little bit. Oh my. Man, Leetcode is just having issues today, I guess. I don't have anything local set up, otherwise that's what I would do. But okay, cool. It gives me something. See. No, the waiting game continues. Oh, why did I do this? No, that's silly. Yeah, what am I doing? I was thinking of someone else. Yeah. And I cannot stop till we go. Okay, well, maybe I'll just put mistakes were made. Maybe I should at some point pay for this speed up thing. Okay, what did I do? Oh no. Okay, whatever. Did it just time out? What did I do? Now I've been running it too often. Because you don't give me the answer. Yeah, sorry friends. Just gonna wait Leetcode queue today. Seems like they were having issues earlier, and now we're still having it. Maybe it just got timed out last time because it's just having so many issues. Yeah, okay. Yeah. Okay, the answers are right. I think in general I would like to, yeah, well, okay, I have some printout, so that's good for kind of checking yourself mentally. So 0 and 4 disconnected, that's good. 4 and 1, yeah, that's what I would expect. And 4 and 2, it doesn't print, so that's also what I expect. So this is good. Something I'm just gonna submit. Yeah, my day's been great. Hang on. Okay. Let me just submit then. So again, the kind of tricky thing about this problem is that we don't know what n is, we don't know what the inputs are, so we might have to do more optimization. Some of this is that we have to, wait, do I have to return it away? What am I doing? Oh, okay, so I have to do a colic. And why did it not complain on the one code? How did was it size of print? Yeah, I guess now that I am running code, my day's been great. Kind of hung out with a bunch of friends whom I don't get to see enough anymore. So a little tired by now, but always time for learning. Okay, so let's submit then. Cool. Oh, look, it's fast-ish and doesn't use that much memory. Okay. Yeah. What do I think about this problem? I think my biggest problem with this problem, well, my biggest issue with this problem is that it's just not very well defined. I think there's a bit of like mind reading or trying different things. Like I could easily see myself doing things slightly in a different way, and then like It's just maybe not what the intended solution is, and then it doesn't pass tests and so forth, right? So I don't know how I feel about that. I guess I don't feel good about it, is what I've been saying. But then that is a very straightforward problem. I'm not sure. I don't know if this is necessary, though it gave me a good time as a result, um, and low memory usage. But well, I guess if we didn't have this, then we just have to times this by 26 roughly, maybe, and that is still should be good, right? Like that's like half a second. So maybe this was unnecessary actually. So if that's the case, then maybe the intended solution is n squared, which is kind of I don't know. I mean, this is way too easy for a problem, I think, if that's the case, because you just need for loops, which is fine. I mean, it's a fine problem for testing certain things, but as an interviewer, I would probably never ask this question because it's not that interesting. And I don't. And then going back, having this could be kind of fun. I don't know if we need to get it in a level in which you need a Bitmask, which is what I did here. But like I can imagine you pre-calculate a set or something in Python, which now that I think about, and then you kind of do a set intersection, which you can do in of n time, which maybe is a little slow depending on how you do it. But obviously I did it here, which is, I mean, it's still technically O of n, or sorry, O of O of alpha, which is where the alpha is the number of characters in the alphabet. And in this case, it's still kind of true if you think of this as comparing n bits or alphabets. Oh my god, these damn. Anyway, alpha number of bits, but it's all of one in practical sense because it's just doing bitwise operation on two integers. But yeah, I mean, but calculating whether two words do not share the same letter probably doesn't merit its own problem, especially if you're having a coding interview that's going like 30 to 40 minutes or maybe even a little bit longer. Then like this, I think it's just a couple of folders. I don't know if there's anything too difficult to understand. So I don't know. So I would probably never ask this question. It's a little bit on the easy side. There's no and also from the perspective of an interviewer, if someone does get stuck, I don't know what I would say, but like they could just implement the naive algorithm, which is very similar to what I have already. So I don't know how much value as an interviewer I would get from learning about, like I don't know how much I would learn about a person's problem solving skills from this problem. So that's why I would not ask this as an interview question. Um, yeah, that's it. I think that's all I have for this problem. Again, if y'all have questions, let me know. This is a little bit on the easy side. It's just a couple of for loops. I don't know if there is, but let me know if I'm hand waving. And if you, I guess I did the complexity earlier, which is that it's n squared before these two loops, and then O of alpha for this comparison. So just O of alpha times n squared. And in terms of space, we have O of n because this is the size of the number of words. And that's